Okay, today we're doing a little bit of review for our semester one final in honors higher algebra. And one of the things that you have to know how to do is quadratics B, which is basically the more advanced word problems related to quadratics. One of which is where I tell you a story about throwing a ball in the air, and you have to know a lot about it. And you use a graphing calculator for this. So I had the kids take out their graphing calculators. And here is the story. This is a graph of a person throwing a ball in the air at 30 meters per second in the upward direction, and the release height is 2 meters. So if you know just that, that's not very much to know. But if you know those two things, you can tell a lot. So answer the 4 questions. How high did it get? When was it at its peak? When did it hit 12 meters high? And a hint on that one, you're going to want to put another equation in your calculator. The 12 meters high equation, since this is height, the 12 meters high equation would be a line y equals 12. You could use the same technique and use intersect to figure out when did it hit the ground. So putting in a second equation for is helpful. All right, I'm going to pause while you give that a try. So I was asked, since it's going to hit 12 meters at both times, the implication, the implied question here is, when did it hit 12 meters for the first time? So you've got a good point. It does hit it twice. But just find me the first moment that it crossed 12 meters. All right, so I'm going to start with y equals negative. Notice I used the negative sign, not the minus sign. 4.9. That key is either x, t, theta, etc., but in this case it's going to bring up an x, because in different modes of the calculator it would bring up different letters. All right, and this is squared, so I'm going to hit the squared button. And then I'd say plus 30. Notice I had to arrow over to get to that plus 30. And then x. And then I arrow over again. Actually, no, it should just work. Plus 2. Cool. Then the first question I asked was, what's the highest that it goes? I don't really need this y equals 0, but it won't hurt to have it there. That's like the x-axis. I'm going to hit graph. And I probably won't be able to see the highest that it goes. No, I definitely can't. So now I need to go and adjust. I can either do a zoom out, or I can go to my window and look higher. Does x control higher? No. Y controls higher. Y max is at 16. I'm going to make it like 50. Now I'm going to just see if that worked. Is that high enough? Yes, barely. Okay. Now I'm going to do second calculate the maximum. Doesn't that sound like the highest it goes? And then on this maximum thing, in case you forgot, you go up and you get to the left. It says left boundary. You get to the left of the highest spot, and then you get to the right of the highest. Notice I'm going to not even make it like symmetrical. As long as I'm to the left and to the right, I'm good. And the last one says guess. That means you guess exactly where you think it is. And you hit enter, and it gives you an exact answer of 3.06. So 3 seconds after I release the ball, it is cresting. It's made its highest moment. And then that was at 47.9 meters, which is about 48 meters, which is a lot. Like, really, honestly, I don't think anybody could throw the ball that high. That is right on the edge of maybe a professional baseball player or something, but that's really hard to do. Okay. And now, the first question was how high? 47.9. When? 3.06. When did it hit 12 meters? Well, it was back a while ago, because this is at 47 meters. 12 would have been a long time ago. How do I do that? I go y equals, and I'm going to change it from a 0 to a 12. And I hit graph again, and I can see the second line come through at y equals 12. That's a horizontal line at 12. There it is. And now how do I see where those intersect? Second, calculate, and on the choice, I go to intersect, which is number 5. And now I just get really close to the spot, and then my advice is just get really close and hit enter for the first question, enter for the second question, and enter for the third question. It'll jump to that, which is at 0.35 seconds. It was at 12 meters. Raise your hand if you were able to pull that one off without my help. Awesome. And then one more. When did it hit the ground? This is when it hit 12. What's the ground? 0. So I change that to a 0. Not 0, 2, 0. There. And now I hit graph, and now I see when it hit the ground. Now there's another way to do this for any math teacher watching. I know there's a thing called finding the 0, but I think it's a lot easier to do intersect. So I go second, calculate the intersect of those two lines, 0 and our parabola, and then I just get really close to where it happens. And intersect, I always just say to get really close, because technically what it's asking you here is, am I on the first of the two lines? Yes, and it'll jump to the other one. It'll say, am I on the second one? The reason it does this is because if you have 3 or 4 or 5 things graphed, you can tell it to find the intersection of just 2 of them. I think since almost every time we only have 2 equations, they should have just made it so that you could just automatically go to one of them without having to choose. Okay, done with my rant for the day. 6.18 seconds. I'm going to round it to 6.2 seconds. It is really hard to keep the ball in the air for 6.2 seconds. Like, that's you'd have to be super strong. Okay. Are there any of these types of questions that you want to ask about? Anything about this topic? Then I have one follow-up question. After 1 second, would you agree the ball has not reached its peak? And it won't be at any nice clean height. It's going to be some decimal height. Do you know the right way to find when it goes to 1 second? Now, some of you are going to grab and look at the table. It's not a terrible way, but there's a better way. Who knows the command that'll tell us if x equals 1, what's the height? So I can calculate. So, second calculate value, I hit enter. And now what's it asking me? It's like there's nothing on the screen. Oh wait, it says x equals. Remember what x is? Is that like iguanas? What is x? Time. Time is 1. And I hit enter, and it jumps right to that spot, 27.1. See how quick that was? All right. That's about every question I can think of that they could ask you on an ACT or on our final. Now that's quadratics B. So I don't want to talk the whole time. I want to give you some time to work. There are other chapters. We'll finish a little bit more like that on Tuesday. I'll go through the last chapter that I haven't really talked about much. And if you have questions, don't forget, I'm making myself available Tuesday morning. Math teachers are normally not available Tuesday mornings. That's like from the principal. He says what mornings you have to be here. I don't have to be here, but I'm going to be here, so if you want my help, Tuesday morning. Or the first day of finals. Some of you guys are freshmen, never had this before. In the final schedule, if you haven't looked at it already, the first 2 hours on Wednesday is a review session where you can come in and ask any teachers any questions for 2 hours. If you're scared about the math test, come in. I'll be here. Or if you want to make up something old or whatever. All right. That's all I got for you for today.